Okay, so before we get started with lecture 32 through 34, part 6, we're going to do a little bit of a preview. Lecture 32 through 34, part 6 is going to be all about graphing systems of nonlinear equations. So before we get started with that, I want to do a little bit of a graphing review with you guys just to make sure that we feel comfortable graphing some of those nonlinear equations they may ask you guys to do. So, first one. I've got a y equals negative x squared plus 3. Okay, what kind of a parent function is that one there going to be? Well, if I'm seeing x squared, okay, remember x squared is our parabola. So our parent function starting out for this is 0, 0, 1, 1, 4, 2, negative 1, 1, and negative 2, 4. Okay, now some things are happening to this parabola here. I've got a negative and I've got a plus 3. Remember when we're graphing these and we're dealing with shifts, we're trying to figure out if something's on the inside or on the outside. So the first part of that review, inside, outside. Okay, if something is inside the function, what kind of a change is going to occur? Well, that would be a horizontal change. Something's on the inside, that's a horizontal change. Something is on the outside, that is when we see a vertical change. Okay, remember when we're dealing with stuff on the inside, it's a horizontal change, but we do the opposite of what it says. When they're on the outside, you do what it says. Okay, if I'm dealing with negatives, negatives are going to cause your functions to flip. Okay, so my parent function here with the parabola, I've got a negative. Okay, now if we remember, in order to be considering something on the inside in a parabola, it has to be inside of the parentheses. Okay? As you can see, there are no parentheses with this x squared, and that negative is definitely not inside of the parentheses. So that is a vertical change, and since it's a negative, that's a vertical flip. Okay? So everything that's up top is going to flip down to the bottom. There's a vertical change happening. So my point 0, 0 stays the same, but then 1, 1 and negative 1, 1 flip down below, and 2, 4 flips along with negative 2, 4. And then the last thing I have is I have this little plus 3 here. Well, that plus 3 again is not inside the parentheses, so that is on the outside, so that's going to cause each of these points to move up 3. Okay? So each of my points are going to shift up 3. And we are ready to graph our parabola. Okay? A little shaky there. Okay, but that is our parabola, dealing with the shifts. Next, we've got our parent function. This parent function is a square root. Okay, so square root of x. Remember, that is the one that has the points 0, 0, 1, 1, and 4, 2. Okay, kind of looks like that. So that's our parent function, right? Now I'm looking at the shifts involved with it. Where is that negative at? Well, this negative is on the inside of the square root, right? So that is going to cause a horizontal flip. Meaning whatever's over here is going to flip to this side. There's a horizontal change occurring here. Okay? So my 0, 0 stays where it is, but 1, 1 flips, and 4, 2 would flip. And then the last part, I've got this negative 2. Where's that negative 2 at? Well, that is not inside of the square root. So that negative 2 is on the outside. So we're going to shift everything down 2 points. Okay? So we could be dealing with square root functions, parabolas. We could deal with absolute values, cubed roots, cubes. There's all sorts of different functions that you guys could deal with. But I just want to do a quick review with our inside and outsides, what all that meant. Okay? And then along with that, we also need to go over our circles. Okay, so remember with our circles, we have a standard form for a circle, which is x minus h squared plus y minus k squared equals our radius squared. Okay, now when we go to graph a circle, I need to find two things. I need to find the center, and I need to find the radius. And those two things will allow us to graph a circle. Okay, so starting out, my center. Well, my center is represented by the point HK. All right, so if I look at my equation here, I've got my H and my K. Okay, but there's something to remember about this equation here, because my equation is x minus H. Okay, and y minus K. So up here I've got a y plus 2. Really, it's got to be a y minus something in standard form. So how did I get that plus 2? Well, that's really a y minus negative 2. Okay, so the point in me showing you guys this is your H and K. My H is really just the 3, and my K is this negative 2. So the center of this circle is 3, negative 2. So when we went over these before, I believe it was on exam 2, we talked about this is my H, that's my K, and when I write my center, I have to switch the signs. So yeah, that says negative 3, positive 2, but really our center is a positive 3, negative 2. We have to remember to change the signs. And then the last part is our radius. Okay, so we want to look in this section here for our radius, but if we pay attention, again, our standard form isn't equals radius, it's equals radius squared. So that means 4 equals radius squared. And if I'm trying to find the radius, I'm going to have to take a square root to both sides of that, which gives me that my radius equals 2. So in order to find the radius, it's not just the number that it equals, you have to take the square root of that number. So the square root of 4 would be 2. So now I have enough information to graph this thing. The center is at 3, negative 2. Okay, so I'm going to go to 3 and down 2. So there's the center of my circle. And my radius is 2. So I want to make a point that's 2 above, 2 to the right, 2 to the bottom, and 2 to the left. Okay, and then I'm going to try and draw the neatest circle that I possibly can. I'm going to be honest, this probably isn't going to look very good. Not bad. Okay, and then I shouldn't need to label the center because we can see where it is on the graph, but I do want to make sure that I label my radius. So I'm going to draw a line from the center of my circle to the edge, and I'm just going to label that, hey, that's 2. Okay, so there's graphing a circle. Let's do one other. Okay, so the next circle that I have is x squared plus y minus 2 squared equals 25. Okay, again, remember our standard form. We need to find the center, which is our h and k. Okay, it's easy to see what my k is, but hey, it's just an x squared. What's my h value? Okay, well, if I think about how I would write x squared in standard form, it'd have to be x minus something squared. Okay, so what would that something be? X minus what would equal x? Just an x. 0. Okay, x minus 0 squared would equal just an x squared. Because if I take x minus 0 is just x. So I have just my x squared there. So if you ever see something that's an x squared or a y squared, that means that your h or k value is 0. So in this case here for my center, my h value is 0, and my k value is a positive 2, because remember, we do the opposite sign when we find those. Okay, so center is 0, 2. Then I need to find my radius. And remember, to find the radius, I need to take the square root of that number, because that's our standard form. So that's saying 25 equals r squared. So I have to square root to find what my r is, and that would be 5. So again, I'm going to come over here. My x is 0, and my y is 2. I've got a radius of 5, so I need to go up 5, to the right 5, down 5, and to the left 5. And this one's probably going to be really ugly. Not bad on top, not the greatest on the bottom. Draw my line across so that I can label my radius. Okay, so that's just a quick review of just graphing some of these nonlinear functions that we're going to have to deal with.